Yes, and welcome to our notes for 5.6 applications with matrices. And then these are really just applications with systems of equations that we're going to solve with matrices. So that's what we're going to be looking at predominantly today. I want to start by stating the work that you're going to need to show when you do these types of problems. So the first thing we're going to have to do is write a system of equations for the situation. And one of the components of that is to be sure to define our variables. Make sure we make that very clear. And that's mostly for us, to be honest. Obviously, this person, Professor Turner, if this is on the computer portion of the test, isn't going to be able to see this work. That's going to be good for us to make sure that we label our variables so we know what we're doing. Next, we're going to write the augmented matrix of the system. And then we're going to use our calculator to solve it with RREF. And then we'll write our answer in the context of the problem. Context of the problem doesn't mean a full sentence, but it does mean we're not writing a coordinate pair or anything like that. So let's look at number 1 here. At a local electronics store, CDs were on sale. Some were priced at $14, some were at $12. Betty bought 9 CDs and spent a total of $114 before tax. How many $12 CDs did she buy? Alright, so there's the question. How many $12 CDs did she buy? We got two variables. We'll say X is $14 CDs. Y is $12 CDs. So in our problem here, we want to figure out what Y equals, because that'll tell me how many $12 CDs she bought. So let's make some equation. Betty bought 9, so if I add X and Y, I should get 9. And she spent $114 before tax. So for every X, she spent 14. For every Y, she spent 12. 114. Beautiful. So from here, we can create a matrix. So that would be 1, 1, 9, 14, 12, 114. And we can RREF it. So let's put this in our calculator. Second matrix, go over to edit. We have a 2 by 3 here we need to edit. So 1, 1, 9, 14, 12, 114. Excellent. So second quit, second matrix, math up to RREF, second matrix A, close the parentheses, enter 103 and 016. 103, 016. So that tells us that X equals 3, Y equals 6. How many $12 CDs did she buy? Well, Y is our $12 CDs. So she bought 6 CDs. Let's say priced at $12 each. There we go. And that right there is the answer to our problem. Excellent. All right, so that's one with 2 variables. Let's look at one now with 3 variables. Together, Teddy, Mark, and Alex have $31. Find the amount if Mark has 3 less than Teddy. Alex has 1 more than Teddy and Mark combined. Wow. Okay, so we got 3 equations here. Well, Teddy, Mark, and Alex, pretty straightforward. We'll say T for Teddy, M for Mark. Oh, sorry about that. M for Mark. And A for Alex. So if I add together T, M, and A plus M plus A, that'll give me 31. Find the amount each if Mark has 3 less than Teddy. So Mark has 3 less than Teddy. So if I add Teddy's amount and subtract 3, that'll give me Mark, right? Mark has 3 less than Teddy. You could also do T equals M plus 3. Either one's fine there. Alex has 1 more than Teddy and Mark combined. So if I add together Teddy and Mark and then 1 more, that would give me Alex. So now let's get these in standard form here, so to speak. So T plus M plus A equals 31. T minus M equals 3 if I subtract M and add 3. And T plus M minus A will equal -1. So there are my systems. Notice my variables are in order now. That's going to be helpful when I convert it to an augmented matrix. So I have 1, 1, 1, 31, 1, negative 1, 0, 3, and 1, 1, negative 1, negative 1. REF. Okay, so second matrix, we have now a 3 by 4. 3 by 4. So 1, 1, 1, 31, 1, negative 1, 0, 3, and 1, 1, negative 1, negative 1. Excellent. So second quit, second matrix. Let's go over to math, RREF. Second matrix A, close the parentheses. 1, 0, 9, 0, 1, 6, 0, 0, 1, 16. So 1, 0, 0, 9, 0, 1, 0, 6, 0, 0, 1, 16. All right. So from this, we can conclude that Teddy has $9. Mark has $6. And Alex has $16. And it's always good to go back in and make sure this all works here. Mark has 3 less than Teddy. Mark has 6. Teddy has 9. Very good. Alex has 1 more than Teddy and Mark combined. 9 plus 6, 15. Beautiful. Very easy to check our answers with these. All right. Let's try one more together. Well, actually, you know what? Why don't you try this one on your own? Why don't you try number 3 and then we'll do number 4 together. So go ahead and pause the video. Try number 3. Do it on your own. All right, let's see how we did here with number 3. So 120 people attended a musical. All right, the total amount of money collected for the tickets was $1,515. Prices were $15 for adult, $12 for children, $10 for senior citizen. Twice as many children's tickets as regular tickets were sold. Okay, find the number of adults, children, and senior citizens that attended the musical. All right, so we have, let's do A for adults, C for children, and X for senior citizens. Now you of course could use S. I don't like to use S simply because sometimes I get it confused for 5 and it messes me up a bit. But if I add all this together, A plus C plus X, that tells me 120 people went to the musical. Excellent. The total amount of money was $1,515. So if I multiply each adult times 15, each child by 12, and each senior citizen by 10, I would get 1515. Now this last one here, twice as many children tickets as regular adult tickets were sold. Okay, twice as many children's tickets. So that means there were 2 times as many children as adults. A lot of us would say, oh, 2C equals A, right? No, that is not the case. It would actually be 2A equals C. I need to multiply the number of adults times 2 to get the number of kids. That's always confusing, so make sure you're on the lookout for that. Now, when I rewrite this for my systems here, I can say 2A minus C equals 0. All right, so from that, I can go ahead and create our augmented matrix. So 1, 1, 1, 120, 15, 12, 10, 1, 5, 1, 5, 2, negative 1, 0, and 0. All right, let's RREF. Put it in this calculator. Let's see what we got. So second matrix, go over to math. Oh, no, we got to edit first. Sorry. 3 by 4. So we have 1, 1, 1, and then 120. We have 15, 12, 10, and then 1,515. And we have 2, negative 1, 0, and 0. Excellent. Second quit, second matrix, math, RREF, second matrix A. Look at this. All right, so oh, screwed it up on me. Let's try again. 1, 0, 0, 35, 0, 1, 0, 70, 0, 0, 1, 15. So what does this mean? This means 35 adults, 70 children, and 15 senior citizens. Excellent. All right, let's try number 4 together. This is a great problem. This is one of my favorite problems from the whole unit. A company makes 3 types of cable. Cable A requires 3 black, 3 white, 2 red. Cable B requires 1 black, 2 white, 1 red. Cable C requires 2 black, 1 white, 2 red. If 100 black, 110 white, and 80 red wires were used, how many of each type of cable were made? So I would let you struggle with this if we were in person, but since we're not, it'd just be kind of crude. The challenge here is that most students would make the equation that A equals 3B plus 3W plus 2R. That's not the way to do this. They give us the total number of wires that are used. So what we need to use here is for each cable, we're going to have a black equation, a white equation, and a red equation. So cable A, so notice the question is asking how many of each type of cable were made. So those are our variables. So we'll just say A is cable A, B is B, and C is C. So for cable A, that was 3 blacks. I should capital letters. For cable B, that was 1 black. And for cable C, that was 2 blacks. And how many total blacks were used? 100 black. Excellent. So there's the first equation. All right. Next one, white. So we have 3 for A, 2 for B, and 1 white for C. I just now saw that I wrote that wrong. And a total of 110 were used. And then for cable A with red, they used 2, and then 1 red for B, and 2 red for C, and 80 of those were used. So here's our equation for black cables. Here's our equation for white cables, or I guess these are wires. So black wires, white wires, and red wires. And then from this, we can determine how much A, B, and C, how much of cable A, how much of cable B, and how much of cable C was actually made. So to do that, let's create our matrix. So 3, 1, 2, 100, 3, 2, 1, 110, 2, 1, 2, 80. And we will RREF. So let's go ahead and second matrix, go over to edit this 3 by 4, 3, 1, 2, 100, 3, 2, 1, 110, 2, 1, 2, 80. Second quit, and let's RREFA. So we got 1, 0, 0, 20, 0, 1, 0, 20, and 0, 0, 1, 10. So remember cable A, cable B, cable C. So 20 of cable A, 20 of cable B, and 10 cable C. Fantastic. All right, for this last one, number 5, notice here they gave us our equations. Our equations was 16x squared plus 4y squared equals 64, and y equals x squared minus 4. Notice we're looking at a planet's orbit and a comet following a parabolic path. In our equations, not all of our variables have the same degree. So will we be able to use a matrix in this case? No. What are we going to have to use? Substitution. So with that being said, let's solve this here. So they already tell us that y is at squared minus 4. So let's do c naught squared plus 4 times x squared minus 4, and I'm going to have to square that, equals 64. We might get some unique answers here. So c naught squared plus 4 times x squared minus 4 is x to the 4th minus 8x squared plus 16, and that equals 64. Now distribute that 4 out, so c naught squared plus 4x to the 4th minus, what will that be, 32x squared plus 64 equals 64. Combining like terms, I notice I can subtract 64 from both sides. That's good to know. Combine these x squared terms here, so I'm going to have 4x to the 4th minus 16x squared equals 0. And from here we can solve this. Notice I can factor out x squared. So when I do that, I'd be left with 4x squared minus 16 equals 0. So I know x squared will equal 0. I also know that 4x squared minus 16 will equal 0. I can divide that by 4. I'll get x squared minus 4 equals 0. Add 4, x squared equals 4, which means that x equals plus or minus 2. X squared equals 0, that tells me that x equals 0. So notice how many solutions do I have here? 0, positive 2, and negative 2. From here I need to plug it back in, okay? So I have y equals 0 minus 4, so that would be y equals negative 4. So that would give me the coordinate point 0, comma, negative 4. Then I have y equals positive 2 squared minus 4, which is just 4 minus 4, which is 0. So that would give me the coordinate 2, comma 0. Then I have y equals negative 2 squared minus 4, which would just be 4 minus 4, which is also 0. So negative 2, 0. So here's an example of a system of equations with 3 solutions. Fantastic. All right. Well, there we go. Those are our notes for this one. Just remember, if they don't all have the same degree, we can't use a matrix. If they do have a matrix, be careful. Or if they do have the same degree, be careful setting up our systems of equations. Make sure we have all our variables in order to make sure we're showing all our work, and then we'll be good to go. All right, well, there's your 5.6 notes. We have one more set of notes for this unit, for this year, and then we will be all done. All right, this is Mr. Carter signing off. I will see you next time.